All right, so we're going to look at what's called collinearity. So this is lecture 23. So some prior knowledge in order to understand what collinearity is about is introduction to vectors, which we spoke about in lecture 19. And in that lecture, we spoke about a vector addition slash subtraction. So definitely go and have a look at that in order to understand this. The key concepts we'll cover in this is basically what is collinearity, and then we'll look at an interesting property of collinearity. So let's go ahead and have a look at that. So what is collinearity? So collinearity is when you have three distinct points, A, B, and C, and they're collinear if and only if there exists a non-zero real number, M, such that vector AC is a scalar multiple of vector AB, where M is that scalar multiple. So what we have here is a slider for M. We can see that these points A, B, and C are collinear because they lie on this line, right? And what that means is that there is a non-zero real number such that AC is a multiple of AB, right? So we can change M, but you can see that AC is just going to be a multiple of vector AB, points in the same direction. It's just that the size is different and we can change that size based on the size of M, right? So we end up with that situation. So those points A, B, and C must be collinear. The other thing we might want to talk about is what's an interesting property of collinearity that sort of falls out as a result of that. So what we're going to do is we're going to create some other point in space. Let's just call that O. And then we're going to create a bunch of vectors going from O to those points. So we've got the vector OA, which we'll call vector A, lowercase a. And then we've got OB, which is vector B. And then we've got OC, which is vector C. And what we can look at is this property of collinearity. So let's just step through it. So let A, B, and C have position vectors, as we said, A, B, and C. Okay, we know that AC is a scalar multiple of vector AB. Vector AC is a scalar multiple of AB, just like we spoke about, if and only if this is true. Okay, vector C, if vector C is equal to 1 minus M multiplied by vector A plus M multiplied by vector B. And then so this is our proof of that. So this is sort of just an interesting property of collinearity, and then we can prove that here. So we know again that A vector AC is a multiple of AB. So then we have that C is vector OA plus vector AC. So let's look at that. Vector C is this one here, right? Okay, but I think you would agree if we added OA and AC using some vector addition, we add this plus this, then we get vector C. So that's what this first line says. Okay, but we know that a vector AC is a scalar multiple of vector AB, right? Again, we can scale that up and down. So what we can say is we can replace vector AC with M multiplied by AB. Okay, so then we know that OA is vector A, but we know also that vector AB, so vector AB is this vector here. Okay, we know that vector AB is actually B minus A, and let me explain that. B minus A, let's just think about this part here. B minus A, another way to think about that is negative A plus B. So it's easy to think sort of using addition. So negative A, so we're going the opposite direction of A. So we're starting from here. We're going this way, negative A plus B. And you can see that that does in fact equal vector AB because we'd travel down here and then up here and then we'd do tip to tail. So we'd get this vector AB. So we get A plus M groups of B minus A. Okay, then just expanding the M in to get vector A plus MB minus MA. Okay, this first term and this last term have A as a common factor. So it's going to be 1 minus M multiplied by vector A plus M multiplied by vector B. So you're probably wondering why we need to know that. Well, that's an interesting way that we can determine if 3 points are collinear by using this property. So when you're doing collinearity type questions and problems, it's important to know this sort of property of collinearity. So yeah, hopefully that is helpful. If you found that at all useful, please give us a thumbs up and subscribe, and I'll see you soon.